Hello, everyone, and welcome to today's webinar, Eclypsium Automata, an expert researcher that never sleeps. My name is Melissa Russell, and I'll be the host for today's webinar. Before we begin, I just wanted to go over a few housekeeping items. We are recording today's session, and we will be making a copy of the slides as well as the link to the recording available, and you should see an email from me by tomorrow afternoon if you're looking for those as well. But if you have any questions during the presentation, please feel free to put them into the Q&A box, and we will be sure to save some time at the end to answer some questions. At this time, I'd like to go ahead and introduce our speakers today. I am joined by my colleague Tyson Supasadet, who is going to be directing our presentation. He is our Director of Product Marketing. Joined with him is Daniel Gutson, who is our Chief Architect and Core Detection Lead here at Eclypsium, joining us all the way from Argentina. And also joining us is our Chief Product Officer, Corey Botson. At this time, gentlemen, go ahead and take the floor.
Thank you, Melissa. I'm super excited to talk about this new technology that we've released, Eclypsium Automata. Today we're going to be talking about digital supply chain security. It's the concept. We'll talk about today's attack landscape and how it's changing and growing, especially in regards to vulnerabilities in components and threats to components. We'll talk about Automata, what it is, how it works, why it's important, and then a little bit about Eclypsium for those who may be new to us, and then we'll have the Q&A. So yeah, as you mentioned, I'm Director of Product Marketing here. With me is Corey Bodson. He's we're going to be talking about the product, and then Danny. Danny, can you please introduce yourself to the audience and maybe talk a little bit about what you do at Eclypsium and your background?
Yeah, sure. Thanks, Tyson. I've been in Eclypsium since the very first month, being one of the initial employees. I've been doing compilers work and static and dynamic analysis for over the last 15 years. And at Eclypsium, I lead the core detection team where we create the detection infrastructure and the most sophisticated detection rules and heuristics.
Great. Thank you very much. So to get started, I wanted to talk a little bit about digital supply chain security. Most people, when they think about supply chain security, think about application software. It's a very, at this point, I think is a pretty well understood problem space. People understand the challenges of being able to inventory all the different software components that go into your applications, being able to scan these assets as they go through the CI/CD pipeline, and then to monitor for new vulnerabilities or threats in production. But people aren't really thinking about, there's not a lot of thought going into the IT infrastructure that underlies these applications, the things that are running the application workloads and sending the application packets over the network to users. There's not good inventory for all the different hardware, firmware, and software components that go into these IT infrastructure equipment. There's not a good way to understand the types of vulnerabilities and risks that are present in these assets, and then also at a fundamental layer below the operating system, there's not good mechanisms for detecting threats. That's why Eclypsium exists. We provide digital supply chain security, especially for IT infrastructure assets, so you can trust your technology. I want to talk a little bit about the types of vulnerabilities that we're going to have to face. First are just vulnerabilities in hardware components. What you see here is research that Eclypsium pioneered. We discovered vulnerabilities in American Megatrends, MegaRack, BMC, software. It's like a little computer that lives in your computer, and that component is used in a number of major, OEM brands of servers. And it was found to be vulnerable by the Eclypsium research team. We also discovered a backdoor in gigabyte motherboard models that also was used, across the board in a number of OEM brands. So at the inside of your inside of your computers, there are computers, and they all have their individual components. And then we've also seen, just over the last 5 years or so, we've seen vulnerabilities in all types of open source software components like OpenSSL, Log4j, most recently with the XZ library. And since XZ we've seen that we've seen this attack behavior targeting other open source projects. So that's quite eye-opening. Earlier this year, there was also flaws found in it's the PXE. It's the network boot library in the Tiana Core EDK2. it's an open source reference framework that's built off to the UEFI spec, but it was found to have flaws. It affects, again, number of vendors. So there's vulnerabilities in these software components, these hardware components, and then there's threats. So usually when we think about threats to this layer, we think about Russia's Sandworm hacking group. They've developed a UEFI rootkit called LoJax, and it's out there in the wild. The Chinese nation state hacking groups also have a UEFI malware that's called Moonbounce. So, but it's not just nation states. So we've seen that there is a commercial UEFI bootkit malware that takes I forgot the vulnerability that it takes advantage of, but it's not something that Microsoft can you have to update your revocation list, and it's just hard to address. I believe the FBI has a paper on it about how you can mitigate it, but there is a Black Lotus malware that takes advantage of this vulnerability, and it does bypass secure boot. It's available for $5,000 on hacking forums. And then recently, just a couple months ago, there was news that the Glup-Teba botnet also added a UEFI bootkit to their arsenal. So it's not just nation states that are attacking these fundamental layers of your computing infrastructure and IT infrastructure. We're talking about routers, switches, VPN appliances, firewalls, servers, laptops. You name it. It's you need to be looking below the operating system. And that's why we're here today. We're here to talk about the new Automata feature, and we're going to talk about why it's important and how it works, and try to answer any of your questions. Danny, we'll start with you. Can you tell us, like, what were you trying to achieve with this new capability?
Yeah, sure, Dyson. I wanted to, especially to depart from the classic fingerprint or signature-based detection technology in order to achieve a broader detection capabilities of threats not previously known. So we built Automata, which is a proprietary system that captures the expert's knowledge to detect malware that was not previously known. Maybe you can progress to the next slide, please.
Sure.
So basically, Automata is based on a rules system that is updatable as known as a database rules database update. So we initially get a binary which is unknown for us. So we trigger all the analysis orchestration, starting with the decompiler, the disassembler, the emulator, and of course the signatures scanning. From the decompiler, we get the decompiled code into large language models, the functional similarity engine that basically asks, okay, I don't know this binary, but what does it look like? What's the semantic I can assume it has? Does it behave like an NTFS driver? Does it look like a network driver? So that's the role of the functional similarity engine. And then we have the C pattern scanner looking for specific snippets or patterns that are usually present in different types of malware, being UEFI, Linux, etc. Then we also have assembly patterns scanning and an emulator, which has a behavior driver. So we have can also have behavioral patterns. So all of these orchestration analysis is driven by the knowledge layer, which is where the expert's knowledge goes to. That's why we have the code prompt, the AI models, the C patterns, the assembly patterns, the behavior patterns, and the binary patterns and artifacts. All of this is triggered by the reputation database of each binary. I want to highlight that this is a technology stack that is used for different ecosystems, being the UEFI for UEFI binaries, Linux user and kernel space, and Windows drivers, for example. So basically, the knowledge layer is specific for each ecosystem, and it is what we are continuously updating and adding more and more knowledge as our researchers develop.
Yeah, and I wanted to, we were trying to calculate the cumulative years of research or expertise in this area that we have collectively here at Eclypsium. I think it's well over 100 years of collective knowledge. For those who don't know, Eclypsium was founded by security researchers. Yuri developed the ChipSec, open source ChipSec framework, and he and Alex were involved in security research at Intel. But yeah, they're providing this this knowledge later. So basically, we're encapsulating their knowledge and understanding of how malware works and how to discover it in the reverse engineering process.
Correct. Basically,
Corey, do you have anything that you would want to add for this slide?
Sorry?
Oh, I was just asking Corey if Corey would have anything that he would want to add on this slide.
Thanks, Tyson. Yeah, just real briefly, I think Daniel covered it pretty well, but there are a lot of security tools out there that help you understand some of the threats and vulnerabilities and IOCs going on. But if you look closely at this, you'll see a lot of stuff that's really unique. Right, I spent most of the last couple decades at scanning companies or NDR companies, et cetera. And there's some stuff that they do, but there's a lot of stuff here that you simply won't find anywhere else. The similarity engine that Danielle mentioned, the ability to decompile and actually look for things that maybe aren't a known signature or a CVE that's released in the wild, but are something like Danielle mentioned, like UEFI doing writes to an NTFS file system that an expert researcher would know, hey, that's just not right. That's something worth investigating, whether it's a known issue or a 0-day. So a lot of really unique technology that the research team has created here.
And
Cool.
this runs continuously on the customer premises. So it is deployed as part of our product. It's not a research tool, it's a product.
Mm-hmm. That's a good point. I know there are, some other companies that do firmware. They analyze firmware binaries, but they require the customer to upload the binary to their cloud-based system. That's key to understand about Eclypsium. Not only do we have this industry-leading analysis system, but we also have a mechanism to continuously monitor for new unknown binaries in your environment and then send them up for analysis automatically. So it's really protection for your production IT assets. Basically, you have a security researcher that never sleeps, and it knows everything that Eclypsium cumulatively knows, and it can analyze the unknown binaries in your environment automatically. Great. Yeah, just I wanted to talk a little bit about what Eclypsium does. We talked a little bit about digital supply chain security, and it's super complex. Your laptop will ship with 10, 11, 12 different major components, things like your NIC card, your CPU, your GPU, the storage device. Our CEO says that software is eating the world, including your hardware. The amount of microcode on a CPU is exponentially larger than it was like a decade ago, and all of that complexity leads to more vulnerabilities that attackers can target. And that's why Eclypsium exists, to give you. We have two offerings. One is our supply chain intelligence guide that allows you to basically query our backend reputation database. We have a reputation database of over 12 million different hardware, firmware, software components. And you can see for any particular product, you can compare the risk of that product based on the components that it is built out of. So you could look at a Lenovo laptop and compare it to a similar laptop from Dell, and you could see, for example, the different components that it could ship with, and the risk score. And then on the opposite way, you can look at a particular component and see what products it is used in. So if there is a new vulnerability announced in a particular component, you can see what different types of products it affects very easily. This is all SaaS. It doesn't require any agents or scans of your environment. You're just basically querying the Eclypsium reputation database in simplistic terms. Now our flagship platform is that provides continuous monitoring and remediation for your production IT assets. And that's where we have various mechanisms to gather that data from your production environment and then look at it, and being able to inventory the different components that are used, create SBOMs, identify vulnerabilities, and assist with patching and remediation. And then when something does go wrong, either you have a potential compromise or there's a supply chain incident, we give you the ability to quickly answer questions. Okay, yeah. I hope that there's some questions. Now would be the time to post them in the chat. Melissa, do we have any questions that's come in from the audience?
There was just a comment about Apple M3 chip weakness, but we do have a few other questions. Give me just one second here. and I'll get them out to you. Let's see.
It's a good comment, by the way, right? The M3, which is as new as a processor can get, and there are already issues in there. And that's actually true, and it's going to be true, right? It doesn't take a security professional to point out. There'll always be some sorts of weaknesses, vulnerabilities, et cetera, especially as things like AI infrastructure get to be much more common and really change what a data center looks like. That's the kind of thing where we're pretty excited to actually be able to provide coverage in both guide so that you can just understand the risk, as well as in our platform to let you start continuously monitoring any issues that may be in that new infrastructure.
We do have a question that just came in. It's from one of our existing customers. He says, I am already a customer for Eclypsium for the hardware firmware monitoring, but the difference of this product is not just to look at traditional software applications for vulnerabilities and exploits, but the subcomponents / SBOM for vulnerabilities. That's the question.
Yes, maybe I'll take a first. Well, actually, Corey, this is why I have you here. Would you mind to address this question?
Yeah, absolutely. So, and let me make sure I understand. So if I get it wrong, please resubmit that. But yeah, subcomponents for vulnerabilities or for unusual behaviors, that's really what the Automata engine allows us to do. And you saw that architecture that Danielle walked through, where we're pulling in all sorts of capabilities, decompiling, looking for patterns, C patterns, looking at weird behaviors that you wouldn't normally see. So this is where a kind of classic software supply chain, they know about applications, they probably know what's happening at the OS, but they generally can't even look, and certainly don't bring a lot of expertise into what's really unusual in a piece of UEFI code, or what's a really unusual pattern to see in a binary that maybe you've never seen before. And that's the kind of capability that our new Automata engine brings, is the ability to look at all those things in a way that really deeply uncovers threats and vulnerabilities.
I think that the question, Mark, let me know if I am wrong, but I think that what you are referring to for the subcomponents vulnerabilities is when you run the SBOM, or you get the SBOM from an SCA, a software composition analysis tool, and you get the vulnerabilities of the indirect dependencies based on their versions. If that's correct, we also do, first of all, we scan everything. We don't care about boundaries or direct or indirect dependencies. We analyze everything. And we also analyze for known vulnerabilities, not only based on the versions, but based on certain capabilities. There are cases where the version is not a very good indicator, because there are cases where there are backports, so the version itself is not a real indicator, so we could have a false positive. So we analyze the content, we do static analysis, and check whether there are traces of the old vulnerable code.
So Mark did clarify. He said he should restate not for hardware. He was talking about the software framework. So another question is, when speaking about SBOM, do you mean SBOM, HBOM, or both of them?
I'll steal Gianluca Katie's thunder, one of our first employees as well, who likes to talk about not only HBOMs and SBOMs, but in fact, firmware build of materials, which is just as important as well. I'll let you figure out the acronym for that on your own. But yeah, that's anything that's infrastructure, which includes, of course, all the traditional components below the OS, network interface cards, processors, also networking gear, industrial and enterprise grade IoT. And as we mentioned, we're starting to push into Gen AI, both infrastructure as well as LLM models. All those things that you can't use your traditional assessment tools to help you understand what's going on with them. That's where we're stepping in.
The next question is, do cloud providers, AWS, Azure, and GCP use your solution on their compute instances? Is there a solution for cloud customers?
So we do have a number of customers who use our solution. We have a bunch of different ways to gather information. Some of those ways are to deploy an agent. Other ways are to remotely assess systems. And that includes via capabilities like Redfish, et cetera. We have a number of people who are interested in assessing some of the virtual infrastructure, VMware, for example, et cetera, that we provide capabilities for. I am probably not at liberty to speak about who our customers are in the cloud space, but suffice to say, anybody who cares about the trustworthiness of the infrastructure that they're running on, we have solutions to help them understand the level of trust they should have in those pieces of infrastructure.
The next question is, how do you get the BIOS images to scan? Do you need to install some agent at the system so it can be monitored? And if that is the case, how do you handle AMD systems that you cannot dump the BIOS from the operating system?
Danielle, you want to tackle that one? That's a good question about how we acquire firmware.
Yes. Yes, there is a sensor that runs on Linux, Windows, and Mac. The sensor gets the firmware, the system firmware, let's say the BIOS, other available firmware, plus hardware configuration, and it sends it to the local install backend. So yes, there is a sensor. And also, I think that the question included the for network devices. So yes, we have a network devices sensor as well, that when available, it gets the firmware. There are some cases, some vendors that provide an interface to obtain the firmware. For other cases, we obtain the other artifacts such as logs, configurations, and we do the analysis with what we have.
Yeah, it's worth mentioning, and Tyson, I'll let you decide if we want to scoop ourselves with RSA, but we are constantly working with vendors in this space. We already work with some of the biggest ones, Intel, TSC, and IDH, Trusted Supply Chain, and Intel Device Health, two things we integrate really well with. We have our partners in the OEM space that provide us the ability to maybe get firmware and do assessments beyond what are publicly published. And we'll continue to work on expanding the size of our coalition to let us be able to always make sure that we can get the firmware either using built-in capabilities, encouraging vendors to add those capabilities so that everybody can, or using special access capabilities that they make available to us.
Okay, we had a couple more questions coming in. Just to clarify, but did you say no agent is needed? Does it mean we just need to connect your broker to your API?
Yeah, I can answer that. I do have a slide on another in another deck that talks about this. It depends on the target environment that we're looking at. Our sensor is going to provide the highest fidelity data. That means we can do more analysis. We can also do authenticated scans for things that can support that, like network gear. For servers, we can utilize the Redfish API. So there are a number of mechanisms that we can use to acquire data about the IT asset. It depends on the target.
Yeah, I'll just add in there, right? We have a whole variety of sensor technologies. Again, the agent gives a very good view and is very appropriate for a lot of places. For systems where you can't deploy an agent, we have remote assessment capabilities. That includes network infrastructure. It also includes things like VMware infrastructure, et cetera. And then we are actually doing quite a bit of work, and this I'm definitely not going to scoop us for RSA, but pay attention to this space. We're doing a lot of things to make sure that we can extend our ability to collect data as new tools become available, as we develop new mechanisms, and as we partner with other companies to provide us the ability to gather data off even more types of infrastructure and endpoints.
Cool. Follow-up question, are you able to scan mobile devices as well?
That's a great question. Danielle, do you know the answer to that? I would give kind of a product manager-y answer to that, but let me let you give the actual technical answer.
Actually, I missed one of the questions. The
question is if we can scan mobile devices.
Yes, I know, but there was also the question about AMD. So regarding mobile, not yet.
And the product manager answer I was going to give is that we are a little more focused on the infrastructure, things like the 5G infrastructure, et cetera. But we also do quite a bit of work and have quite a bit of coverage in what are more traditional enterprise IoT devices. Mobile, what we've found thus far is that the ecosystems tend to be pretty good for understanding what is there and keeping things up to date. It's an area we'll keep looking at, but our focus right now is on those areas like kiosks or industrial IoT devices where there isn't a good ecosystem and there isn't good visibility. So that's my PME way of saying, if you think you have a clear need, we'd love to talk to you. What we're hearing right now is that while that is important, our customers and prospects are really looking to us to cover some other areas in the infrastructure right now.
Last question.
I would like
sorry.
also to follow up. Sorry, yeah, I would like to also follow up on the question about AMD. We currently have, or we currently get the BIOS dump through more than one interface, not only the SPI, but also the MMIO. For some models, we can get the BIOS dump. I would like to also comment that we are contributors to the Linux kernel. So in the case of the Linux kernel, we are also contributing for the SPI, other equivalent subsystems.
Always one of my favorite questions is, can you show a brief demo of your product?
I can. I've been chomping at the bit. So yeah, I'll try to make this super quick. Unfortunately, I mean, this can't be like a full demo. We'd love to, answer your questions like with our team. But here you're looking at our dashboard. We're showing you this is the kind of the CNN news ticker for your environment. We're showing you detections, coverage updates. We even make recommendations on, hey, if you're going to do one thing, you should probably update this one, this one desktop. So also this second bar is, filterable. So I've clicked here on client PCs. So we're looking at desktops and laptops. You can see there's 27, there's 27 different vendors, 174 different assets. If I look at just this group, so you can create custom groups in Eclypsium. Now this group is made up of different laptops and servers. Mostly it's infrastructure devices. And now you can see the asset, the threats and vulnerabilities and baselines have all changed. So we're just looking at the 27 devices in this particular group. And then any of these you can drill in on. So I drilled on like critical detections for this group, and we see that there's these we have some Avanti and Fortinet and Cisco devices that have been compromised. We were talking about Automata and the ability to discover threats. If I go over here to known threats, now this is looking at the entire demo environment, and it'll show you different types of threats that we've detected. Malicious peripherals, that Black Lotus that we had mentioned before. So Automata doesn't have a UI, but that's powering all of these threat detections. Now we've gone into a particular device, and we can see the different components that are part of this device, and then the yellow is an indicator that there's some vulnerabilities, it needs some updates. The red is the indicator of that there's an implant, there's a malicious implant on this component. So if I click in there, I can see, okay, here, this is where we have the Black Lotus detection for this bootloader. So, and then it will give you more details about the scan. So that's just kind of at a high level. If I go into the assets list, we can see primarily we're targeting client PCs, servers, network devices, but we also look at like virtualization infrastructure. You can drill in to say a particular manufacturer if you wanted to look at those gigabyte motherboards. You can do that. You can see all the systems that have the gigabyte motherboards and so forth. If I wanted to look at like HP storage devices, I can do that. I can see all of the systems that have HP storage devices. And if you wanted to look up a particular model, you can do that as well. I had in mind there was a certain HP SSDs a few years ago that had a really interesting bug that caused them to crash and lose data. So hopefully that gives you whets your appetite a little bit. We'd love to show you a full demo. You can request that on our site.
Thank you, Tyson. There was one question that came in just after you started the demo about Android. Somebody has non-mobile devices that use Android. Are we not focused on the Android OS?
Yeah, I think we're I don't know. I think we might have answered that. If I remember, Corey said, we just it's a different environment, and it's not our focus at the current time. But we'd love to talk to people if they think we ought to. Yeah, Mike has a question about sending findings into the SIM. Absolutely, yes, we can. We can send alerts and issues about security configurations, things that don't have secure boot enabled, that are left in manufacturing mode. We can send all of that type of information to ticketing systems and your SIM and SOAR.
Great. Well, I think that concludes all the questions that we had. I want to thank Tyson, Corey, and Daniel for joining us today, and also to thank our audience for participating today, and we hope to see you on the next webinar. Thanks again, everybody.
Thank you.
Thank you. It has been really fun.